Hey, Ingo, it's time for, well, you know, 5 minutes with Ingo.
Right. Okay, cool. Let's think about today. We are going to talk about, I think we talk about decision trees today.
Yeah.
So,
Hey, Ingo.
hey Glen, how are you?
Good.
Decision tree.
Whoa, 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 whoa!
Oh.
Oh!
Oh my gosh, Glen.
I'm so embarrassed.
You know what? I just realized, Graham, something very, very interesting just has happened.
Okay.
You just did something.
What did I do?
Well, you reacted. You've seen something is happening, and then you did something.
Yeah, glass broke.
Yeah, you're right. But you said like, what? Whoa, 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 whoa.
Yeah.
Then the glass broke, so it was falling down, and you've seen it, and you said like, okay, watch out. There's something happening soon. Isn't that true?
Yes.
Yeah, well, how did you do this?
Well, I saw Glenn come in and grab a cup and stand over there, and I could tell he was going to drop it because he's a bit clumsy, and
But
I looked over and the glass was going to fall.
Right, but how did you know that's going to break?
Because I've seen glasses break before.
Okay, so you made some experiences in the past?
Yes.
Isn't that interesting? You never have seen this particular glass breaking before in your life.
No.
You never have seen this glass falling down, and you couldn't know that this glass is going to break.
Right, not that one.
Actually. Not that one, yeah, but you've seen similar things.
Yeah.
Okay, you know what? Forget about decision trees. That's a stupid, boring topic anyway. We will talk about this another time.
Okay.
Let's talk about something completely different.
And now for something completely different.
And this is very, very interesting because, in my opinion, this is how human beings, you and I, really often are arguing and create machine learning and data mining models in their head. We use similar situations, and we use those similar situations to actually create predictions. So let's have a look how this happens. So you have seen cups falling down, okay?
Yes.
You have experiencing those situations in your past. Fine with that. You don't know something about this particular cup falling down, but you have seen similar cups. And maybe they have been breaking in the past. Now for a new situation, you say like, well, this is somewhat similar here. So you could argue it's going to break as well because you made the experience in the past, and then you compare the current situation with the situations you've seen in the past, and
Yep.
you say like, okay, I know what happened back then, so I say it's very likely it's going to happen again. So you say it's going to break. Cool. What you just did is probably one of the most common data mining algorithms in your head. We actually say it's a lazy algorithm, and you will say understand this in a second. But you did it in your head, and I find this really exciting because that's true for so many machine learning methods that they're inspired by how we are actually thinking. They try to model the brain to some degree at least. Neural networks claim to do that. And K-nearest neighbors, that's what we are talking about now, actually very similar. They use the way how you argue with me, for example, to explain why something is going to happen. Okay, so let's for the first time actually in our 5 minutes with Ingo series get a little bit more mathematical now. Let's just assume we have like data which described in 2 dimensions. So you might measure some things like, I don't know, for example, the hardness of the glass or the cups, and also that's not a good idea, the height, which is used which you measured actually for cups falling down.
Mm-hmm.
So you have some cases where, let's say, the height is very high and the hardness is not very high. So let's say those are the cases you measured in the past, those orange dots here. And then you have other cases where you say like, okay, the height is low, the hardness is high. Let's say those cases where you say, okay, I've seen the blue case in the past where the cup didn't break. All right, now the big question is, for this situation here, is this an orange or a blue case?
Orange.
Wasn't that easy? Why?
Yeah. Well, because it's grouped with the other orange
Exactly.
dots.
It's very similar. It's very close to those here,
Yeah.
but it's not very close to those. So this concept here of similarity is very important, and that's why we call this k nearest neighbors. Because we look at, let's say, the 3 nearest neighbors, and we look, is this now a break case or not? And then we just say, like, okay, this new situation is also going to be a break case. That's how the prediction is created. Well, and that's all I can say about k nearest neighbors, and actually even without using any formula. All right, so that's from my side on k nearest neighbors.
Cool. And this has been your 5 minutes with Ingo.
Okay, data scientist number 7, come here, clean it up.